Okay, so our first question we have here, we have, let me get the drawing mode. Oh. Okay, we have a unit step function and a ramp function. All right, so, oh, it doesn't like that. Let me put that back up there. How do I, I don't know. Okay, so for this problem here, we have a mix of unit step functions and what we call ramp functions. And we're going to define that as u of t. And we can basically call this, we'll say it's like continuous time. It's flat and or an instantaneous jump, like so. And we'll say ramp. Usually they do like a little cursive r, but I'm going to say r of t, which is the ramp function for time. These are the slopes that you're looking at here. There's one here. I can't draw on that. But there's where you see it increasing and decreasing are the ramp functions. Okay. So we're going to go in more detail as how we graph this. And our first drawing, we have something like this. Okay. So we have it's flat here, goes up, down, then flat. Okay. So where we're going to start is we're going to start where where it changes on the graph from the center. And that's where we're going to start. So yeah, so when we're changing, this is our beginning, and this will be our end, but we need to define the end, and I'll go into detail about that. So we start off, negative 20, negative 10, call this 50, this is 10. Okay, let's zoom in down here. All right, so we start off coming from negative infinity, and this point is where we change. So how do we define this slope? Well, the format will be r of t plus 20. This is defining the x-axis where it's placed at. And then in front of this r will be its slope, which will be, it goes from 0 on the y-axis to 50. So it's going to be 50 over 20, right? Rise over run. And that will be the slope, which is basically 5 over 2. So that is the initial slope. And that will define the slope as it goes from here all the way to the center axis. Yeah. And then we need to define this right part. Well, this is how I like to think of the ramp function. The ramp function is like setting the slope for the function, right? So think of it as the slope is still here, it's present. That sounds weird to think of it like that. So you have to offset that slope that you initially set here. So let me go into an example. So the slope here is decreasing, obviously. It's going down from 50 to 0 and 10. So we're going to say 50 over 10 is that slope, right? Which is basically 5. minus, but we also have to take account the slope that we set in the beginning, which is 5 over 2. So it's going to be 5 plus 5 over 2, which will be 10 over 5 over 2, which is 15 over 2. So minus 15 over 2. R over t minus 10. That is our x-axis that we're putting in there. So the reason we offset our initial slope is because this acts as like setting the slope, and we have to turn it off because we're changing. Obviously our slope becomes negative here. We need to offset that by adding this slope plus the slope it already has and making it negative. I hope that makes sense. And then this is the where it places on the x-axis where it ends. That is its end point. And now, as it goes on, we need to define the end. It's a unit step at the origin. Okay, so now that we have to remember, we set this slope in place, right? So in order for the slope to be flat here, we have to cancel out that slope here. 15 over 2, it's going to be a unit step of t minus 10, because that's where it leaves off. So think of the front of it as you are setting the slope, and you have to negate it as so. And this is our function that we end up getting right here. Now, if the question asks to convert to only unit step, you can do that, but this is right. And the question asks use step functions to write the expression. Oh, so no, we're gonna have to convert them anyways. So that conversion is, the equation is as follows. It's not that big of it's pretty understandable. This is the equation right here, right? And how you would do that in terms is basically r of t is equal to t u of t. So whatever this t value is, right, you are putting it here and here for the thing, or the unit step, and that's it. So it would be 5 over 2 still. So our t value for r of t is t plus 20. So wherever there's a t, replace that as so. Minus 15 over 2, that's the slope in front. And to convert, you plug in the t, where t is t is t minus 10 u of t minus 10 plus 15 to u t minus 10. And that is our final answer. Nice. That's question 1. Now let's do question 2. This is A. Now let's do B. I'm going to draw that down. Okay, so we have our graph drawn. Part B. Okay. So we start from the center, right? In this picture, we start from the center, where it first starts changing, -9. We have a ramp function there. Here's our ramp function. Okay, so we need to set a slope. So what is our slope setting going to be? Well, we go from 0 and we go up 15. So our rise is 15. And our x, it goes from 9 to 6, so that's 3. So that ends up being 5. It's a positive slope. It's going up. And we start for r at t plus 9. That's for the negative x-axis over here. If you want an explanation for that, if you do t plus 9, solve for t is equal to negative 9. Makes sense. Okay. And now we're here. We need to offset that slope. Remember that. So we're positive 5 up. To offset it, it's negative 5. Okay, and it's a unit step. And we're starting at negative 6. So it's t plus 6. All right, so our slope, we need to turn on that setting again. We go from 15 here all the way down to here. So we go 30. It gets a whole thing of 30, goes from 15 to negative 15. That's 30 through that whole slope. Negative 3 to 3, that's 6. It's 30 over 6 slope. It's negative. What is that? It's negative 5. Yeah. Negative 5 slope. Okay. So we got a negative 5 slope. It's a ramp function, and we start at t plus 3. Okay. Now, let's get rid of this. That's confusing. Now, we're at this point here. Okay, we're flatting out, so we have to offset that slope again. So it's going to be plus 5, since it was negative 5. Unit step. That's going to be at t minus 3 there. Okay, now we need to put our slope back on. We're getting a little long here. So we go up 3. No, it's up 15, my bad. Negative 15 to 0 is up 15, so it's going to be 15 over 3, so it's a slope of positive 5, so it's going to be plus 5. It's a ramp function of, we started at 6, so it's going to be t minus 6. And from there, from this point, we need to flatten out. So we need to turn off the ramp, or the slope. So we need to negate it with a negative 5. Unit step, and that starts at t minus 9. Okay, and that is that. Now we need to convert this to unit step. So yeah, this is what we did. Let's go through it all. We start with the slope here at 5. We go up 5 at 9. Stop at negative 6. Negate the slope. Turn on a negative slope. Go down here. And we start that at 3. Turn it off here at positive 3. Negate the slope that we had. We flatline, and at 6, we turn on a slope of 5. Negate that slope, and we go off into infinity. Okay, now let's convert everything. So we know that r of t is equal to tu of t. So let's plug that in. So wherever t is will be on u. So let's do the first one, 5. Now t is t plus 9, so we have t plus 9 u of t plus 9 minus 5. That's already unit step. Minus 5 t plus 3. Hopefully you're getting the pattern now. T plus 3 plus 5 u t minus 3 plus 5. Okay, we got an r here. So we got a t minus 6, u, t minus 6, minus 5, u, t minus 9. And that is our step function. That is what is defining the part B here. So yeah, this is ramp and unit step functions put together. So yeah.